There are two pieces of basic Sudoku logic that you need to understand to solve puzzles. The first is the elimination of possibilities using position, and the second is the elimination of possibilities using values. To understand positional elimination, we will start with a simple example. Suppose that the digit 1 appears in row 4, column 6 of the puzzle. From this fact and the rules of Sudoku, we know that a 1 cannot appear anywhere else in row 4 or in column 6, and it can't be anywhere else in box 5. So this single digit eliminates a large number of possible locations for another 1. Now let's look at another grid that has a few more digits filled in. Take a look at box 3, and let's think about the digit 5. It turns out that we can deduce its location even though there aren't many digits filled in. Let's look at the other 5s in the grid and think about how those digits eliminate possibilities for box 3. This one eliminates the top row of box 3, and this one eliminates the bottom row. And these two eliminate columns. And now when you look at what's left, there's only one place the 5 can go. In fact, whenever you have 4 of the same digit that see the same box, you can always get the location of that digit within that box. The reason is that 2 of those digits will eliminate 2 rows, leaving you with only 1 row for the digit, and then the other 2 do the same for the columns. A similar idea works when cells are occupied by other digits. Consider this example. The 7s in boxes 4 and 6 eliminate these rows as possible locations for the 7 in box 5. But in the remaining row, 2 of the cells are already occupied by other digits, so there's only one place the 7 can go. Let's change gears and look at another situation. You can see that there's a value missing from this column, but since there are 8 known digits, we can deduce the value of the last one and fill it in. If there were 2 values missing, we could reduce the number of possibilities, but without further information, we wouldn't be able to logically conclude what that value must be. Now consider this arrangement, and let's focus on row 1, column 1. If we look at the column, we see that this number cannot be a 1, 2, 3, or 4. And if we look at the row, we see that this number cannot be a 6, 7, 8, or 9. And if we combine these two pieces of logic, we see that this can only be a 5. The same thing can work using rows, columns, and boxes all at the same time. By combining all of this information together, the value of a cell can sometimes be fully determined. When you're doing this for yourself, you obviously won't have all the digits float over to the side to easily see which ones are missing, and so there's a little bit of mental work to do to keep track of the digits that you do see. It takes a bit of practice, but it's not hard to do. This type of reasoning has been given a name by the Sudoku community. It's called a naked single. It is the second of 2 core pieces of logic that you need to solve puzzles. Most of the skills that you develop from here are just extensions of these ideas.